All right, so this problem says a river is moving east at 4 meters per second. So a similar problem, except that it's not a plane, it's a boat, and instead of wind, you have the water moving. So exactly the same problem. Yep. So boat starts from docks heading 30 degrees north of west. So at 7 meters per second. If the river is 1800 meters wide, what is the velocity of the boat with respect to the earth, and how long does it take the boat to cross the river? Okay, so now in this problem you would have to use the technique that we used in the previous problem. Okay? All right, so let's do a diagram first. So we'll draw a river. The river is flowing 4 meters per second. Okay. Our boat travels 30 degrees north of west. West is this is west, and this would be 30 degrees north of west. Okay? And we'll give all these guys labels in a second. 7 meters per second. Okay. What is the velocity of the boat with respect to earth, and how long does it take the boat to cross the river? Okay, so this is the velocity of the boat with respect to water. This is the This is the velocity of water with respect to ground. Okay, and velocity of boat with respect to water plus velocity of water with respect to ground will give you velocity of the boat with respect to ground. Right? So again, velocity of boat with respect to what? Will give you velocity of boat with respect to ground. Okay, that's what we're interested in. So again, when you add vectors, what is it that you want to do? You want to write the components. Okay, so let's write their components. Velocity of water with respect to ground, this is easy. Again, I'm assuming that that's 4I plus 0j. Velocity of boat is minus 7 cosine 30I plus 7 sine 30j. Okay. And this is all right, so right now all we've done is we've set up the problem. Okay, we've written our vectors in component forms and we've drawn the diagram. Okay, we haven't done any calculations yet. All right, so now let's, what is it that we're trying to find? We're trying to find the velocity of the boat with respect to ground. So it's this vector plus that vector. So I guess I'd better, so velocity of boat with respect to ground is minus 6.06I plus the other vector is 4I plus 0j. Okay. So this is minus 2.06I plus 3.5j. Okay, so if you drew this vector, the boat is, there is the velocity of the boat with respect to ground. Okay, it still has an x component. It has a negative x component. Okay, and so if you were the pilot of this boat, you are not crossing the river in the most efficient manner. You would be using more fuel. You're ending up going across the river in that direction. Okay? And so today, airline pilots, they charge you money for baggage. What they're trying to do is minimize fuel costs. So if this guy were a pilot, he wouldn't reach his destination for one. He'd have to go like that, so he'd end up wasting fuel. Okay? So anyway, this guy is not headed in the optimal direction. All right. Now, what is the goal? How long does it take the boat to cross the river? Okay, so to cross the river now, it doesn't matter whether he crosses like this. What distance is he traveling in the y direction? 1800 meters. Okay, so we'll calculate that. Okay. So let's look at the y motion. Y minus y naught is v naught yt plus 1/2. There's no acceleration in the y direction, so this is 1800 meters, and the y component of his velocity is 3.5 meters. Okay. 3.5 meters per second times t. Okay, so it takes him 520 seconds, which is roughly 80 minutes, or 8 minutes. Okay. Yep. The test is a multiple choice question, so it'll. All right. Do we have any other questions on that one? Yep.
For the velocity of the water touching the ground, was it 0J just because it was just the force of the water had no y?
Right. Right. Yep.
Will we get scared?
No, I'll provide a scan. Yep. I'm sorry? So this is minus 6 plus 4 is minus 2. Any other questions?